Hello everyone, hope you all are good. Welcome to your own mathematics channel asm.geniusjunction. I am Abhishek sir, your mathematics mentor. In today's video, we are going to cover AS level mathematics 9709 unit 1 quadratics. This is third video on the unit 1 quadratics and there will be total number of 3 videos as we have already disclosed in the first video itself. Please watch video number 1 and video number 2 to understand the concepts which are discussed in this video number 3. So without wasting time, let's start. Yes. So in this video number 3, the topics which are going to be covered are solving a quadratic inequalities, the number of roots of a quadratic equation, and the intersection of a line and a quadratic curve. Right? So these are the 3 topics which we are going to cover in this particular video. So starting with the first topic of this video, solving quadratic inequalities. Please observe this question very carefully. In this question, you are given a quadratic function and the inequality says that it is greater than 0, right? So we need to find the values of x for which this particular inequality holds true, right? So let's start with the solution part. What we need to do is we will use Middleton splitting concept to solve the given quadratic function. So I will write x square minus 5x minus 14 is greater than 0, right? So we will use the Middleton splitting concept. I need two numbers whose product should be equals to minus 14 and their sum should be equal to minus 5. The two numbers are going to be 7 and 2, right? So I will write the given quadratic equation with the middle term splitted in two parts with minus 7x plus 2x and minus 14 greater than 0. Now I will take out x common from the first term, so I will get x minus 7 plus 2 common, I will get x minus 7 again greater than 0. In this way, I am getting two factors, x minus 7 and x plus 2 greater than 0. Right? Now, we need a very basic concept after this particular step. We are having two numbers or two factors multiplied together and our answer is going to be greater than 0. This is possible only if this is positive and this is positive, or if both of them are negative. Right? So according to this situation, if I plot the graph of this particular function, then our graph is going to appear like this with its two roots as minus 2 and plus 7. Now, as the inequality says that the curve of quadratic is greater than 0, we will consider the values which are greater than 0 for y, right? So we can see that all the values of x less than minus 2 or all the values of x greater than 7 are going to be the part of the given equation, right? So we will say that this is the set of solution which satisfies the given inequality. Please pause the video and note down the solution. Yes, so now this is question number 16 in continuation with question videos number 1 and video number 2. Now, this is your 16th question and this question is based on the concept of quadratic inequalities. So first of all, we need to split the middle term. So we are having x square plus 4x minus 21 less than equals to 0. Now we need two numbers whose product should be minus 21 and their sum should be 4. So the given numbers are going to be 7 and 3. Okay, so write down So let's factorize the middle term of this question. This is x square plus 7x minus 3x minus 21 less than equals to 0. Yes, so now we will take out x common, so we will be left with x plus 7 minus 3 common, and again x plus 7 less than equals to 0. This is now we are getting x plus 7 and x minus 3 as the two factors of this given quadratic equation. Now, as we know that the product of two numbers are is less than or equals to 0 is possible if they have opposite sign. That is, if x plus 7 is greater than 0, then x minus 3 should be less than 0. And if this is negative, then the second factor is need to be positive. This is the only possibility when we get the answer less than 0, right? So let's solve this. Yes, to find out the solution of the given inequality, we will plot a number line, and this is your minus infinity, this is your plus infinity. We will plot the critical values, that is minus 7 and plus 3, and now we will plot the set of values of x which satisfies the given inequality, right? So the set of values of x which are going to satisfy the given inequality says that x should lie between minus 7 and plus 3. So this is our solution set for the given question. Please pause the video and note the solution set for the given inequality. As we all know that a quadratic equation means that its degree is 2, so it can has its roots up to 2. That means it can have no root, or it can have one root, or it can have maximum of two roots, right? So a given quadratic equation ax square plus bx plus c equals to 0 is having a discriminant d which is calculated by b square minus 4ac. If the value of this discriminant comes greater than 0, if the value of discriminant comes greater than 0, then we say that the roots of the given quadratic equation are going to be real and distinct. Similarly, if the value of discriminant b square minus 4ac is equals to 0, then the roots of the equation are real and equal. And if d is equals to b square minus 4ac comes less than 0, it means that the given quadratic equation has imaginary roots, right? How this actually appears? The case 1 is represented by this figure in which a quadratic line is having two solutions, right? In case 2, a quadratic equation is having only one solution, and in case 3, quadratic equation is not having any solution. It is not intersecting the x-axis, right? Let's move on to understand this concept in detail. Okay, so question number 17, in continuation with video number 1 and 2, let's discuss. Find the value of k for which the equation 4x square plus kx plus 1 gives you 0 and it has equal roots. We know that for equal roots d is equals to b square minus 4ac should be 0, right? So this is your equation 4x square plus kx plus 1 equals to 0. So I will write d is equals to b square, that is k square minus 4 a c equals to 0. Then I will write k square minus 16 is equals to 0, and we get k is equals to plus minus 4. Therefore, we can say that the possible value of k is equals to k is equals to 4 and k is equals to minus 4. So this is the solution or for the value of k for the given quadratic equation, right? So if we put k is equals to 4 in this equation, there will be d is equals to 0, it means that the roots are going to be equal. And the same goes for k is equals to minus 4, right? I hope you understand the concept. Please pause the video and note down the solution of it. Now we are moving on another very important question based on the same concept for finding the value of k for the given equation. And this time we need to find the value of k for which this quadratic equation has two distinct roots, right? So this time we need to find the value of k for which the equation has distinct roots. What we are going to do is, first of all, let's move on with the solution part. For distinct real roots, we have d greater than or equals to 0. We have d greater than 0. It means b square minus 4ac should be greater than 0 for the given quadratic equation. So I will put b square minus 4ac, that means minus 2k whole square minus 4. In place of a I will put k, in place of c I will put 8 greater than 0. Solving it, we get 4k square minus 32k greater than 0. Take out 4k common, we get k minus 8 greater than 0, right? And now since two factors are having their product greater than 0, it means k can have its value greater than 8, or it has its value as less than 0. So these are the two possible set of values for the function which is given in this question number 18. These are very simple questions in which we need to use the concept of discriminant. Okay, moving further. Now we have reached on next topic of this video, that is intersection of a line and a quadratic curve. There are three diagrams which are there in front of you. First of all, we will understand how we need to First of all, we will understand that what actually line and curve intersection means. A quadratic curve is represented with the green ink and a straight line is represented with the yellow line, and we can see that the line and curve are intersecting each other at two distinct points, A and B, right? When the two equations intersect each other at two distinct points, the discriminant for the resultant quadratic equation is going to be greater than 0. If the quadratic curve and line touch each other at only one point, or we can say that the line is tangent to the curve, in that scenario the resultant quadratic equation has its d equals to 0. I am talking about resultant equation, not this quadratic curve equation. Okay, I will let you know how to solve this question. The third case in which line and curve are not intersecting each other, so there is no point of intersection, and in that case the resultant quadratic equation will have its d less than 0, right? Let's move on to the question part of this particular topic. Yes, so this question says that find the set of values of k for which y is equals to kx minus 1 intersects the curve y is equals to x square minus 2x at two distinct points, right? So what we are going to do, first of all, let's quickly write down the solution of 19. The two equations involved are y is equals to kx minus 1, this is the equation of line. Let's say this is your first equation, and y is equals to x square minus 2x, this is your equation of quadratic curve, and I will say this is your equation number 2, right? So strategy says that equate equation 1 and equation 2, right? So when I will equate both of them, I will get kx minus 1 equals x square minus 2x. When I will shift the coefficients on one side, we will get a quadratic equation as x square minus x plus 2x plus 1 equals 0. This is called resultant quadratic equation. This is your resultant quadratic equation after equating the equation of a line and curve, right? All the rules which we were discussing in the previous page will be applicable on this particular equation. Now, question says that find the value of k for which this equation has distinct points. Distinct point means that d should be greater than 0. It means that b square minus 4ac should be kept greater than 0, right? So I will write b square, that is minus k plus 2 whole square minus 4a, that is 1, and c, that is 1, greater than 0. Okay, so let's make a quadratic quickly. So we will get k square plus 4 plus 4k minus 4 greater than 0. That gives you k square plus 4k greater than 0, right? Solving right here only. So I will take out k common and I will be left with k plus 4 greater than 0. Now again the product of two factors greater than 0. So as we have done in this first question, so the same way we have done the previous question, we will do it in this question as well. So I will write k is greater than 0 or k is less than minus 4, right? So this is your solution set for the given quadratic equation with the given condition. Yes, so that's all for this particular unit. We have done all the parts which are given as a Cambridge curriculum for Unit 1 Quadratics in AS level mathematics. Okay, so thank you so much for watching the videos. Please do not forget to subscribe, like, and share the video to get timely update on Cambridge AS level mathematics 9709. Thank you so much.